on Thursday, added an index buffer to this, which allowed us to more efficiently render some complex geometry. And we also introduced a depth buffer. So here we can see we've clearly got two squares that are at different depths in the scene, and they overlap correctly. So that was mostly what we looked at in the previous stream. Let's tidy up our to-do list. Let's see if I can get refile to work here. Oops. Refile, use index to this Thursday. I guess that, and we'll do that. I didn't actually get in the right one. Yeah. This is. I think I'll probably start actually timestamping these correctly. So, yeah. So we've got the index buffer, and we made use of the depth buffer. I think now is actually a good point to just stop and slow down a second, even though we're not exactly going quickly. But my feeling is, if I look at this quake-3.hs file, we're up to the best file, 1600 lines, which is a lot for one file, and compilation times are getting pretty slow, and it's hard to really understand what this module is actually doing. So I want to focus first today on forming a module structure. There's a way to move these things. Don't worry about it for now. Do it the old-fashioned way. So I want to form a module structure, which basically means that this thing should, main should really only be exporting main, and that shouldn't actually be doing too much either. It should be deferring and stuff to other functions. And stuff's kind of quite nicely split apart here, like we've got create window, get needed extensions and stuff. So let's see if we can break this apart just into some small modules. And also what I want to do is, I've mentioned before in some previous streams that like a lot of stuff kind of implicitly needs the physical device or a device or some kind of context that it operates in. And I'd like to probably move that out of being a function parameter and threading it through with some monad. So what we're actually going to use today is a library that I've actually been really enjoying. I wasn't sure at first when it first came out, but the Rio library is really nice. So Rio stands for just reader IO, and the fundamental monad we get here is tucked away weirdly, maybe into advanced running functions. No. But it's essentially reader T over IO with some variable environment. Here we are. Why is it in accessors? That seems a bit strange. I don't think it's meant to be there actually. But anyway, here it is, the reader plus IO monad. And it's not a transformer, which is nice because it actually makes things a little simpler. So this is what we're going to use, and I'm going to thread various parameters we need through this. I think it's going to work anyway. But before we get to that, let's get this module structure in place. So let's start with instances. But, Okay, so that's just stuff we're going to need to bring in here. It'll be a little tedious setting us up for the first module, but most of these is just going to be a copy and paste job. So I'm not entirely sure where to put some of these functions, but I think this manage Vulkan resources, like so general foreign.vulkan seems appropriate. It's kind of interfacing with like a foreign interface. Let's throw that in here. Refresh itself. Cool. Why is this now suddenly stop type checking? It doesn't really make any sense. Oh yeah, no, we had to introduce our own managed. Don't really belong in this module. Okay, so somebody has mentioned that they've switched from managed to resource T. I have a handle to resize and need to release just a subset. Yeah, so I did think that we might end up having this problem. So basically, when using this managed monad transformer, or monad, it basically pushes all deallocations right to the end. It might not be the right thing to do. And kind of for exactly the reason that's been mentioned in the Twitch chat. We'll see for now. We can always come back and change these things. Yeah, I don't know where to put this manage function, but I'm just going to drop it into here for now. I don't think we need to export it, to be honest. In terms of resource management, I also considered using regions, which are kind of a generalization of the width abstraction that we've been using. But that tends to be really type heavy, so I'm not sure about that one either. I'm sure we'll just find out over time. what fits us best when we understand our requirements a little bit better. Everything type checks? No, I didn't think so. Yeah, you know what? Let's stick this in control monad managed extra. Resource T's acquire function is very similar to managed. Oh, managed bracket, yeah. Okay, so apparently the refactoring won't be too hard if we have to do this, which is kind of good, so I guess that maybe we accidentally converged on a pretty useful API here anyway. Just got the implementation slightly wrong. Not working on Quake-3, not there yet. Monad managed extra. That's the one that needs rank n types. Keyboard layout is Dvorak, and I'm also doing this, if you can see that, on a split Ergodox keyboard. 329 allocate and peak. Yeah, that's not really got anything to do with Vulkan either. Let's take that out. Put that in foreign. Marshall extra. Good. So that's one bit of Vulkan abstracted away. Not a bad API, just create Vulkan instance. What I'm thinking I might do as well is I kind of want this Vulkan namespace to be the only thing that actually imports graphics.vulkan. Which is the case so far, but it's kind of leaking some of that namespace back out. So I might end up coming up with some new types here, and certainly, I mean, we're hard coding this entire create info beyond supplying the string. I might have all of these create things kind of take a record as input. But that's getting a little ahead of ourselves there, so let's leave that for now. So we've got create Vulkan instance. What about physical device? Let's add that. And the reason I mention that is you could imagine, like, maybe way into the future, we use Backpack or something like that to abstract our rendering backend out. So we would have a signature for the renderers, and and we could plug in like an OpenGL renderer, a DirectX renderer, the Vulkan renderer. I don't know if we're going to ever get around to doing that, but it's just good API practice as well to keep things separate responsibilities. So create physical device. Come back and do the warnings later. So this isn't technically anything to do with Vulkan, but like we're very much assuming a Vulkan idiom, so I am going to put that one into foreign Vulkan. It's technically a little bit more polymorphic than that, because these Vulkan pointers are actually just foreign pointers anyway. And like this, it's just null pointer, alloca and peak array. Oh, it's fetchable. Vulkan, fetchable. Cool, that's one more done. So why don't we just go through this? Oh man, that function is way too big. Definitely need to sort that out. Can we put that in here? Yeah. There we go. So I don't know if this belongs in the physical device module or maybe something different. It only uses the physical device, so let's put it in with the physical device for now. Come on. Got there in the end. So call this create logical device. Vulkan terminology, it's actually just a device, so I'm going to do that renaming at the same time. Nope. There we go. There. Swap chain. So this all kind of fits into this Windows system integration concept in Vulkan. So let's just have a module for that. Both of those can go in. That one as well, probably. Ah, that's why this file keeps type checking. I've removed that. Right, that also. Let's get that. Good. Oh yeah, thanks for joining us. Let's get a frame buffer module, same thing as before. But what? Huh. It's kind of interesting doing all of this separation and creating all these modules to kind of actually just acknowledge how much we've had to write so far. I knew we were going to be writing a lot of code, but we really have got through quite a bit so far. This is all command buffer stuff. Let's bring all of that in. Actually, command pools are something different. Okay. So I think it was a render pass thing came out next. Yeah, record render pass. I think that goes in the render pass module. Actually, maybe it's command buffer. What does it do? To really begin render pass. No, I like that more in the render pass module, you know. Because I actually think we're probably going to change that to be... We'll probably change that... Maybe I should do this right now. Should I bracket this? Maybe not. Do something like that. Now then, so these have got to be lifted. That's kind of nice. Let me do the same thing for our command buffers. Say with command buffer, do all this stuff. That needs to be added here. Wow, still got 1,000 lines of code in there. Mad. Never mind, we are getting there. Acquire next image, that's really part of the WSI module, I think. As is present. So my kind of goal in doing this refactoring as well is like we might end up with quite a nice high level Vulkan library of some sort that other people might want to use to avoid having to do all of the setup stuff I've done so far. If you're willing to pay the price of maybe like agreeing with my opinions on how I've laid things out, but also maybe paying a slight allocation cost or runtime penalty because I'm going to use more of Haskell than the low-level bindings would be willing to use, because they're trying to be as close to the metal as possible. So getting a key, that's probably part of a device. Even, that's better. So submit to command buffer. So a lot of these functions kind of have namespace identifiers in them, which I'm not a huge fan of now that we've got a module hierarchy, so we'll probably go and rename those and use some qualified imports instead. But let's get this stuff out of the way first. I don't really need that anymore. There's a lot going on there. I noticed here as well that we're loading some shaders. A little bit suspicious. Probably want to break that out. Where is it? Here we are. this is interesting. What are we going to do about this? I think what I'm going to do is we'll start work on the Quake-3 namespace now. We can move the definition of a vertex there, which I think is just, yeah, it's just a type alias for now, but we are going to be changing that. Good. Okay, so I'm going to kind of slightly deviate. That's a good idea. No, I'm not. Okay. We'll specialize the context of vertex buffer and index buffers into proper types. Maybe outside. Oh, maybe not. Let's stick it under buffer. So I'd be curious if anybody knows if a buffer can change its type once it's been created. My guess is not, in which case the context of a vertex buffer is something quite intrinsic to the Vulkan API, and I'm willing to put it into the Vulkan namespace. But if a buffer can change, then we should probably only have a buffer type, and the concept of a vertex buffer can be something that we introduce outside our Vulkan API. For now, I'm going to put it in here. Vertex buffer is just a Vulkan buffer though. Cool. Oh, look at that. We're down to 500 lines now. This is looking very nice. Okay, so this is also going to end up being tied to our vertex definition, which is not good. To be honest, yeah, I'll leave it for now. I've kind of got some ideas of maybe stuff we could do there. Why is change to space not doing anything? Weird. Okay. Just going to stick all of this descriptor stuff into one module. Maybe this is just descriptor. I'll do descriptor step now. Okay, so it's complaining that update descriptor set is being given a uniform buffer where it's expecting a buffer. That is definitely hard coded at the moment to be a uniform buffer, so the uniform buffer here. I say it's hard coded because you can see that down on line 166 here. We're definitely saying it's a uniform buffer. So let's bring that in. Probably an option there to use a type class for this update descriptor set, but we're not there at the moment, we don't need that, so nothing to worry about there. Guess I'm going to have to expose what a uniform buffer is. Oh, you still with us, Emacs? Seems to have killed it. There we go. Not happy about something. Oh, yeah, great, that's exactly what I wanted you to do. Thank you. Right, so we're going to have to export the details of what a uniform buffer is. And that means I can then just coerce. That's going to complain that it doesn't know. Well, this doesn't help. It's going to complain that it doesn't know what a uniform buffer is. So the coerce system in Haskell needs the constructor to be available so it can see that they have the same underlying representation. Let's bring that in, and it's happy with that. So bind vertex buffers. Yeah. Well, let's put this in our vertex buffer. So what I'm doing here is I'm just taking a list of vertex buffers as input, but we also need to provide an equal length list of offsets. And this nice operator here lets me just replace every element of a list with a constant. So I'm just saying for every vertex buffer in this list, replace it with a 0, and that gives me a list of offsets. So nice little trick there, if you haven't seen that one before. I knew that looked suspicious. BK command buffer. You can let me coerce here. Should be able to coerce that entire list into a list of, yeah. That's exactly the type we're looking for. And coerce should let me do that because a list can be coerced into a list, and a vertex buffer can be coerced into a VK buffer, as long as we actually import. So import Vulkan buffer, vertex buffer, the constructor, that in scope. Oh, what am I talking about? We're in the module. Oops. Oh, that. What does that 1 mean? Looks suspiciously like the length of the list, in which case first binding is the index of the first vertex input binding. Binding count is the number of vertex input bindings. Yeah, probably that then. Why? What are you on about? This error is completely in the wrong place. Better. Find vertex buffers. So let's just get this index buffer out, and I think it could be everything except maybe the depth buffer. It looks like you can only specify usage on buffer creation, but you can, multiple usages. That's interesting. Does complicate things a little bit. So yeah, that was just in response to my question a while ago. I was just kind of thinking out loud: was can a buffer change how it's used over its lifetime? It turns out the answer is technically no, it seems, but a buffer could be used for multiple things. So you could like upload vertex data to it, and then you could like suddenly change its usage to be a different type of buffer. But I don't know if we need to worry about that for now. These can just be fixed buffers. Like I suppose you could always create a buffer that could have multiple usages. Some kind of like a union buffer or something like that. What's this? Physical device indices. lost that line. Hopefully that was the right place to do this. This is getting there. Yep, just one of them. Yeah, it's a bit of a weird specialised function, but it can go in image for now. Not image view, image. Go on, Emacs. It seems to hate opening new files. So yeah, create depth image like feels very specialised to put in this Vulkan namespace, but I don't have a better option at the moment. Alright, so we're all good. Does it still work? Oh yeah, gotta sort that out. We might get a link error. Okay, sweet, still works. So, shitload of warnings to go through. How do I give GHCI warnings? Allows us to run even with warnings. Maybe just do it here. Yep, I'd say that's it. So let's just tidy these warnings up, and then I think we can call this little bit of work complete. Oh, actually, there's a couple of things in Quake-3 that still well, so basically, yeah, the goal, I suppose, is to we shouldn't have any dependency on Vulkan API in here. I don't want to re-export those. Yeah, I'll specifically bring the imports back in and we can narrow that down. Definitely should need that. Is he going to be clever enough to help us out here? Cool. So, VK format D16 you can get in there. Okay, so file buffer, pipeline layout, descriptor sets. Gonna guess that 1 is probably the length of the descriptor sets pointer. Just have a quick double check. Descriptor set count. Yeah. I don't actually know what the type of those things is. I'm okay with that one. Kind of do want all of those options. So that goes. I don't think we should have that there. Oh, that's part of the fences. We do have a to-do item to sort that out, so. Basically the idea is, at the moment we're going to basically kind of only ever have one frame in process on the GPU at a time. But that's a bit of a unnecessary performance hit. Like, we might as well be processing multiple frames at the same time, but if we took QA idle out, we could in theory end up with like 20 frames in flight, which is just mad. You can't respond to 20 frames in the future. If for some reason we get blocked on like another thread or something like that. So we'll use a fent at some point to limit that to maybe 2 frames being processed in parallel, but we're not there at the moment, so. Oh. Bind descriptor sets is 67. Okay, so let's go through and start having some fun. Damn it, there's only reverse errors. No, I don't want to do that. Basically, one. That's not that annoying. It's moderately annoying thing is that like all of these warnings get reported top to bottom, but obviously if I remove a line, all my line numbers mess up. If I could get, is this going to work? Maybe this has fixed itself. Ah, good. Okay. Forever garden unless we'll go. What the hell just happened there? So this is quite nice basically. I'm doing my compilation in Emacs, which then has like a pretty good go to error type thing. What the fuck? What's happened there? Does not have field P inheritance info, but it does have P inheritance info. That is bizarre. Well, that's a problem. Oh, what? This is all gone really weird now. How have you got yourself in such a pickle? Let's clear the build cache. Also commit while we're here. Okay. Might end up with the same error, in which case I don't know what to do. But hopefully that's will have fixed it. So if we were on GHC 8.6 as well, I've just remembered there's a really cool source plugin called Smuggler, which I think if you just enable, just goes through all of your modules and deletes, and like literally rewrites the source code to delete any unused imports. Really cool. So that would be perfect right now. But unfortunately this is GHC 8.4 because 8.6 isn't out yet. So we're stuck having to do this manually. But it's quite therapeutic. Love deleting code. Probably one of my favourite parts of programming is deleting stuff. Oh no, it's gone out of whack. Oops. Ooh, nope, need one of those. It's happening again. This is so strange. Oh, I'm wondering if it's because we're deleting too much from here. Like one of them is actually needed for orphan instances or something like that. It's pretty messy if that's the case. What have we deleted from this command pool? No, don't do that. So we've taken out, well, that shouldn't be it. The only Vulkan API pings is just the KHR surface and KHR swap chain, but that's nothing to do with command pools. What if we... Let's force recompilation from the start again. It's kind of weird, it always seems to get a little further along. do actually need some of those. So you don't need matrix multiplication, N44V2, identity, perspective, translational. Okay, so it just needs V3. Why? Okay. Yeah, alright. Oh, this is looking good. Cool. I'm getting RSI on my elbow from this. Yeah, so I'm pretty sure we found a GHC bug, because like it's all compiling fine now, but sometimes incremental recompilation seems to just completely go absolutely mad. Could be a bug in Cabal as well, I suppose. Not necessarily has to be GHC. Somebody is doing the wrong thing, that's for sure. am a serious stickler for a maximum of 80 characters per line. Probably a little bit too much, but hey. I've mentioned in a previous stream, like part of the reason I kind of take my formatting to the extreme is because it actually points out interesting code smells. Like if a big block of code seems to get formatted into this huge mess, then that code is probably doing too much. And in fact, we do have that here. Like this is one function, and it's huge, way too huge. We should probably pick that apart at some point soon. Let's double check it's all compiling anyway. Okay, great. Commit all of that. Oops. I think we can check off formal module structure. Done. So we were going to use Rio, and now I'm not entirely sure if we should. And that's partly because Rio doesn't have a good way of kind of changing its type of environment. Maybe this isn't problematic. But what I mean by that basically is if we look at this Quake-3 thing, like at the beginning, there's a lot of things coming into scope that just didn't exist before. So like here, our environment has nothing, and then it has a window, and then it has an instance, and then it has a physical device. But once we've created an instance, once we've created an instance, actually, you know what? Yeah, what I was going to say is once we create an instance, like we do have a teardown as well, so we need to clean that instance up when the program terminates. So we kind of want to keep track of that cleanup in our monad, but our monad is going to change type. So maybe I'll leave it for now. So how did we get on with that? That must have that was a fair bit of refactoring. Okay, so technically our code base grew by quite substantially by 700 lines, and that's probably just the repeated imports and stuff, but I'm happy with that because our Quake module has gone down to 300 lines. Much nicer. I think we can like break out a lot of this initialization stuff as well if we have like Quake-3 init. Call it something like that. I really don't know why Emacs is having such difficulty loading new files. It's really weird. Let's generalize that. Okay, so it's pretty much all of this stuff. All the way up to Break all of that out. Keep those separate. Command buffers can be separate. Maybe that's it. Game's a bit too suggestive. We'll just go with action. So now main changes to with quake-3 context. Do it that way. Okay, so what do we need out of this context? The physical device. Yep, it certainly doesn't. Actually, here. I think I'll just put it in here and rename this. Okay, just let Emacs like crash briefly. Cute. So now you can just add these things in. So it needs a device. case swap chain KHR. Qualified import of that and that are redundant. Create descriptor pool and create descriptor select. Yeah, those guys. Whew. Alright, so now our main Quake 3 module is down to just 160 lines of code, so we're getting there. My kind of intention here is I want to break out like what is happening frame by frame to do the presentation. So let's break main apart into just two small things. So one can be resources, which for now, let's just do this stuff. Yeah, okay. That's to return some resources. So vertex buffer and index buffer. Indices, I guess. Let's see what's happening with that. Where I'm going with this as well is I want to add a first-person camera during today's stream. So we're going to start looking at like a kind of logic loop, but I need somewhere to put that logic loop, and we don't have a good place for that at the moment, I don't think. so they've got to be Word 32s. Right, so what have we got now? So our main loop, I want to see these things a bit more. Yeah, I thought that might happen. Okay. Probably needs context and some resources. What do I call that again? Render to frame buffer. What are you complaining about here? Oh, right, yeah. So now we have a way to turn context resources in a frame buffer into a single command buffer that does the rendering. Good. Yeah. I've got a better name. Just go with frame for now. So what do we do per frame? Okay, so I don't know what the best place to insert some logic into this is, but actually, let's have some kind of logic module which talks about like the general quake-free game independent of any graphics. And what we'll just try for now is let's see if we can just have a camera that progressively zooms out from the 2 squares that we've currently got on screen. Yeah, so if I could just have this camera zoom out or something, or maybe oscillate in and out with a sine wave, that'd be a nice start. So let's just have like step, which takes that's like quake-3 to something like that. Eventually this is going to start introducing like a delta for the amount of time that's progressed per frame, what the input from the input devices are and stuff like that, but we'll go with this for now. We use C float. Yeah. Oh, actually, no. Just do that. Go with 0.001 for now, just because I don't want to fly out of the screen. I don't actually know what my frame rate is. So we're going to work out how to update one of these things. And I think because our uniform buffer was created with coherent memory, I can just basically like re-upload to it. So I need to like my initial state. And the camera's just at 0, 0. Just hack it in that way for now. So this now, maybe I can never remember which one it is. We're going to use a state mode now, and I can't remember. Actually, yeah, it doesn't really matter. It's never going to terminate. So. No, I don't want to put a state mode over that actually. Let's do it that way. So So I'm with Michael Small on this one. Like, if you're in the IO monad, you might as well take advantage of it. Like, you've got mutable variables, so use them. I like that a bit more. We're going to need to interpret that, so let's export everything and initially set. So I'm not sure. I guess we could probably have a separate rendering thread, but I'm going to worry about that for now. For now, we'll update our logic and then we'll do a render. So 0 is read IRF data. Want to avoid having to keep lifting these over and over again. We you know what? Do this. It's just depend on unlift IO for now, which I know happens to have these lifted. So I guess the process of going from a logical description of the world to something that's on the screen is essentially rendering, right? So I think the forming of a model view projection matrix is something particular to graphics. So I'm going to add Quake 3 render as well. It's kind of weird. There are like two bits of rendering. One is like take all of the GPU resources and turn them into something on the screen. And the other one is take the logical state of the world and update GPU memory. So maybe that's like update resources or something like that. I don't think it needs to know what resources are. This is a kind of fun bit, I think. Like, I don't really, now I'm definitely back to that state where I don't really know how I want to do this, so it's quite fun exploring different API choices. Oh, GHC environment files strike again. You might need resources then. What do we have in resources? The vertex buffer, the index buffer, and the indices. You don't need any of those. In fact, you don't even need resources at all. Yeah, this is feeling nice. We're getting somewhere here. Might move that logic into state or something like that. Or maybe model. Model might be nice. Yeah, let's move this file to model. So the reason that needs model is because it's going to do update from model. I guess it takes resources. Right, so I need to re-upload into the command buffer. That's generally when we created the buffer. I guess it's when we created the uniform buffer. Where the heck is it? I can create buffer. Must have been the wrong file. Yeah, we do this map memory stuff, so maybe I should take that out. So also, it's worth saying that I received, I think it was yesterday, somebody tweeted me, let's see if I can get this open, tweeted me a fork of the zero-to-quake-3 project that uses push constants, which is definitely something we are going to look at using. So maybe we should just use push constants right now. Oops. How do I get to my forks? Yeah, so we've got push constants here, which isn't a huge change, and in a sense it simplifies some things, because we just need to basically do push constants and give it a new pointer rather than mapping it up, mapping a load of memory. I think I'm going to leave it for right now, and we'll just do this when we do update command buffer. No, update buffer, sorry. Which takes a VK buffer. So we're starting to lose a bit of type safety here because it's going to be it's going to be possible to upload different data into a buffer. Technically, that's not wrong in the Vulkan API, but it's kind of wrong in our usage. We want to keep things consistent. But I'm not going to worry about that for now. Poke buffer, I think, seems more appropriate. I want to use data, but as a keyword. Contents, I guess. That is exactly what we've rewritten before. It's nice. Nah, it's not entirely, is it? Oh, no, yeah, because the poke function gets abstracted. Do that? Did I get that right? Poke buffer with buffer as well. Oh, that's really annoying that we need a device. I don't want to pass the device in. I still don't understand why you have to pass a device in when a buffer is created against the device. So, how am I going to store this? Oh, let's be honest with the low level bindings for now. That poke really seems like it should be the first argument. Oh, but I don't know I don't have access to that memory thing. Is there an index file here? It's the quick reference. Oh, that's quite nice. Oh, look at that. The little notes column that you can fill in yourself. You're only allowed to make that many notes on the whole of the Vulkan API. This is the quick reference. I like it. It's a big API. Let me have a look at the Vulkan tutorial. I imagine what you've got to do is maybe keep hold of that memory. Do they do any? I don't know if anything's actually animated on this. Okay. New transformation every frame, yeah. Blah, 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 blah. Yeah, so they got access to this memory object. Okay, you know what? I think what we're going to have to do... Let's just combine these things. In fact, just owner. Time to completely break the API. No, we're not going to break it too much. When the quick reference has an index at the end, yeah. Maybe suggest it might not be a quick reference at that point. Okay, device memory. So poke buffer with doesn't need that anymore. Maybe I should just call it device, to be honest. Then I can use record wildcards. What should I call that? Let's do res. Result. Yeah, I guess let's put that in there for now. No, actually, the size in bytes. It's that guy, isn't it? Yeah, okay, so now those lovely coercions I did can no longer be coercions, unfortunately. actually did the wrong one, but we are going to have to do that one anyway. Script set's unhappy with that. So with all of that, I should now be able to poke, buffer, uniform with model view projection from, what do we call it? Camera position. Recalculating the whole thing is a little redundant, but it doesn't matter for now. I guess it doesn't really matter what this is. Just put 0 in for now. But you don't know what that is, of course. Let's call this uniform buffer. Okay. So the linear library has a function called lookat, which forms we can use to get a view matrix. Linear. So let's use that. Why make this in Haskell over C++? So yeah, get asked this question every stream, but it's a good one. So for me, I've been writing Haskell for about 6 years, so it's like my go-to language for doing just about anything. So I'm just very familiar with it. So the goal of this project is to learn Vulkan more than anything else, and we've got like good low-level bindings to the Vulkan API that basically look like C. So that lets me learn Vulkan rather than learning, say, somebody's particular interpretation of the Vulkan API. Like if I was to use Unity or something, I wouldn't really be learning Vulkan, I'd be learning Unity. So by using a language that I already know about, I'm able to concentrate on just learning the interesting things, which is Vulkan for me. But also I just kind of want to prove that you can do this, or maybe we'll find out you can't do this. It'll be a good learning experience either way, but I'd be surprised if we can't. Because I think Haskell is a perfectly good like systems language, low-level language. It can be very efficient if you write it in an efficient way, which is the same as, C++ doesn't just magically become efficient. You've got to write efficient algorithms in C++ to get the benefit of it. So yeah, for me, I want to learn Vulkan, so I want to learn as few things as possible at the same time. I want to concentrate on just learning Vulkan, but also I want to demonstrate that this is like a very viable way to do game programming. And I think we're going to benefit from having a good type system behind us. Where is this then? Projection? It's not a projection matrix, but it might be in here. So basically, lookout is going to take, it takes a forward vector, takes the I vector, which is what we're looking at, which is for now the camera position, plus the forward vector. Our center is a camera position, and our up vector is just pointing directly up the y-axis, which might be -1. So we now need look at, and we need vector addition. Such a happy operator. Just say that poking shouldn't return anything. We want it purely for its side effect of changing some memory. Cool. I don't think I'm calling that update function. So that should be called every frame. I am calling step, which steps the model forward. But before we do that, we then need to render update from model. Yeah. Which now does need some resources. Nope. Moment of truth. Let's see what happens. We should expect a camera to either zoom in or zoom out. That's a bit annoying. It wants to rebuild a load of stuff. Never mind. It's there again. So strange. Okay. So I didn't add the model and the render. that, and we're just going to have to force it to recompile, I guess. I love it when you finish all of the code that you're actually working on, and then all of a sudden something else breaks. Completely anticlimactic. It could be GHCI interacting weirdly with this. I think it's just like its interface files are just falling out of date or something. It could be something to do with the custom type errors not playing correctly with things. It's a little annoying though, because the whole point of splitting this apart into a nice... Why are you recompiling again? I don't know why that's compiling twice, that doesn't help either. But yeah, the whole point of splitting this apart into nice separate modules was to have faster recompilation, which we don't get that now. Okay. Are we going to zoom out? Are we going to zoom in? Or we're just going to like crash? We could do that too. Oh dear. That doesn't look good. In VK bind buffer memory, attempting to bind memory to object which has already been bound. Okay, that's fine. I think I know what we're doing there. We are repeatedly binding memory in this poke, which is wrong. We actually bind the memory once when we create the buffer. Floating point exception. Never seen that before. Oh, come on. It must be GHCID interacting with this weirdly. I'll sit back and let that compile again. Oh, I do know I'm on 8.2. I am quite far in the past there. Might try updating that to 8.4. So the latest GHC compiler is 8.4. 8.6 is about to come out. I've just noticed here from this compilation log that we're on 8.2. So this could be a known bug that's since been fixed. So we don't see anything. Let's change the model for a moment to just keep the camera fixed. Yeah, I'm going to turn that off for a second. It could be that this is incorrect. We might be looking the wrong way. That's one thing to check. I suppose in theory so that's the identity matrix, which is what we were previously using. So in theory, if we had a camera that was looking forwards from the centre, facing directly up, this should be... Is that the same matrix? 1, 0, 0, 0, 1, 0. So I think we're looking backwards. think I is position of the eye in center. Really? Okay, so somebody said that I might have got my eye and my center coordinates mixed up. That actually works. Should we? Let's double check. So here is GLU lookout or glue lookout. So I suppose the position of the eye point. I think, yeah, you might be right actually. Center minus eye suggests that eye looks at center. Yeah, I'm with you on this one. So, what have I just said? I is where we are. Okay. So in that case, it probably was -1 there. Cool. That's good. And then go back and update our model to slowly, or maybe very quickly, depending on my frame rate, zoom us out. Yeah, those pixels are changing. We're definitely zooming in, aren't we? Let's increase that by 10 times. Awesome! That looks like 3D graphics to me. So demo scene. Demo scene with a very, very unimpressive demo. That's cool. So that kind of starts to prototype our camera. Check all of this in. Sweet, yeah. So the next step would be to drive some of this movement from the keyboard. So let's get WASD in for now. Also, it might be worth saying there, the reason I'm doing this camera kind of this early on is because I think the very next step for this, once we've got the camera, the next step for this project, once we've got the camera in place, is to load actual BSP levels in. The problem I've found in the past though is if you're fixed at 0, 0, the level might be defined way out in some, like, there's no reason the level has to be centered at 0, 0. And it's really tedious, like gradually rotating the camera around and things like that. What would be nicer is if we have full mouse control, full WASD, then even if the level's in some weird position, we can at least kind of walk ourselves over there or something like that. With like, maybe we'll use really, really far Z-planes just to make sure that we don't lose it because of the depth buffer or something like that. Okay, so what do we want to input to this model? In fact, actually, I'm just going to be right back for just a moment. I just want to grab a drink. Okay, so yeah, what I'm unsure about is what gets input into step. But it's probably an action. Like, we'll create a record call action, and it's probably going to be at least like maybe acceleration or something like that. But for now, it could probably just be impulse. So the idea here is we're going to process SDL events, which will give us key presses. I'm going to translate that stream of SDL events into a single action, and then the action gets given to the model, which can then update itself. So it's quite nice to decouple the progression of the model from physical keyboard and other input devices. Let's have something like that. Right. I think I might actually make actions a monoid, because basically per frame there could be multiple SDL events that we need to process. For example, there might be mouse movement and the user is holding W down. In SDL, those are going to be communicated as two separate events. So if I make action a monoid, I can basically fold map over all of the events I see in a frame, turn it into an action, concatenate all of the actions together into one, and then pass that over to our step function. So SDL event to quake-3 model action. Quake-3 model. So we can do poll events to clear the event queue, which we're going to do every frame. I don't think there's a fold event, is there? No. Step the existing state with fold map. So what is an event? I don't care about the timestamp. I think we want keyboard events. Anything else goes to empty. Keyboard event data to an action. And why don't we just say, if you get any one of these, then for now it'll be an action, the impulse of something like that. Not entirely convinced that this SDL event to action thing should know about like the concept, like what strafe means or what moving forward means. It should probably be mapping to more higher level events. So if you press W, that translates to move forward, and something else can work out what move forward means. But for now, let's just have it directly construct these actions. What if this works? We're doing. Ah, that's a shame. Kind of wanted to use basically deriving via, which is an 8.6 feature, to make it easy to write this monoid. The best way. Yeah, I really want deriving via here. So what I can do is just like use sum and stuff here. Yeah, so in 8. So someone said action is not a new type, and you're right. But in 8.6, I believe like deriving via works for larger data types as well. We're gonna have to kind of somewhat. I could either write this monoid out by hand, but I don't really want to have to do that. So I'm just going to use these new types and deal with the pain of having some new types. So we can derive generic, and then I can say where empty. What's this called? Deriving? That's not how you spell deriving. So mempty equals Oh, come on, fingers, work with me. Missed 1D? Whereabouts have I missed something? Cool. I think, yeah. So that suggestion that of a typo was something like that seems like I probably already fixed it. Just a bit of a stream lag there. It's just generic. What? Oh, it's this bloody environment file again. Okay. Ah, that's the missing D. Yeah, you're right. There we go. We got there in the end. Take it down anymore. Cool. Looks like that's good. So this should mean, yeah, this should mean for any key press we'll like jutter forward a little bit. Obviously, we're then going to do some pattern matching here to find out when we press W and when we press A, S, and D, and change our impulse accordingly. Oops, I probably should have re-entered the next shell there. So what we'll be interested in is maybe the input motion. Yeah, we only care when a key is pressed. Ooh. No, this isn't event, is it? Oh, it is, okay. I wonder if the problem is these HI files are getting dropped around by GHCI. That might be what's causing the strange compilation errors. DL. So that's because I released a key and I've got this slightly wrong here. What? Why aren't you recompiling? Oh, I must have forgotten to add it into here as well. Cool, so holding W sends me backwards. It's also got this horrible property that like the key repeat, I don't know how to describe it. Like obviously if I hold W here, that is the W key on my keyboard. Like you get that little delay, and we're getting that, but the proper way to do this will be to introduce much more intelligence into like our step function of the model. But I'm gonna not worry about that for now. This is good enough. So let's pattern match on the key being pressed and see if we can do something interesting there. So what was that? Keyboard event key sim. I'm going to use the scan code. I think we've got a big table somewhere of scan codes. Yep. Apparently it's already in scope. Is this one already in scope? Yes, good. That's going to crash if I press anything other than W now. And I think it also goes the wrong way. Let's use something slightly higher velocity. So W goes forwards. S goes backwards. A goes along the negative x-axis. And D goes along the positive x-axis. Anything else is 0. I just realised pure is there everywhere, so let's... Nope. Yeah. Factor that out. Oops, let's put this on the correct screen for you guys. So, hold W, move forward, hold S, move backwards, A goes the wrong way, and D also goes the wrong way. So, but that's weird. Like, what? I've got these, I set these axes up really weirdly. So this means my z-axis is going in, my x-axis is going that way. Well, that's just a normal right-handed coordinate system, I guess, right? No. What have we got wrong there? I think it could be... I think we might be upside down, actually. So, yeah, so I recall from the last stream we found an article of like that Vulkan uses a different coordinate system. Its normalized device coordinates are a left-handed coordinate system, whereas previously in OpenGL they were a right-handed coordinate system. So that could be what's going on here. I think if we basically flip the camera upside down, then strafing left and strafing right should work. Yeah, so someone said I think Vulkan flips the normal y-axis. Yeah, so there we go. Well, that's pretty cool though. So, the beginnings of a first-person camera. We can't look around or anything. It definitely works. Magic. I agree. Graphics programming definitely feels like magic sometimes. So, what's this? Can I bring us over here? Yeah, so someone said this is probably what I was looking for with coerce. Oh, I see, right. But yeah, you have to wrap everything up in action. Yes, but what I really wanted, like my long-term plan here, or at least where I was kind of going with this, was to be able to say something like coerce empty at some v3 float. I don't even know if this makes sense, but like some quaternion of float. So I was going to use the monoid instance for tuples and then coerce that back into a monoid instance for a record of multiple fields, which you can do with deriving via. We'll just do generic deriving for now. The nice thing there is I would be able to drop all of these new type annotations, which are going to get really annoying. Right, so why are you saying that there's unsaved changes? I guess it was, yeah, flipping the y-axis. So let's bring this in. Okay. I think, yeah, let's just see if we can get mouse control in. I'll probably wrap the stream up there. We've been going for the best part of 3 hours now, so you guys must have things to do with your days. I'm not sure I do, but it can't be. I'm not going to be writing Quake 3 all day. So we've got another action, which is going to be to rotate the camera a little bit. Let's go with some angles. So I need to store these angles, camera angles. We may look at just storing a quaternion or something like that in the future, but for now a pair of angles should do the job. We're only rotating, basically I think we're rotating around a fixed axis, so I don't think we have problems with gimbal lock and things like that you can often get with storing Euler angles. So rotate, no, camera angles. That's a bit suspicious as well. Maybe that was the problem of why we were moving the wrong way on the axis actually. We should be negating that. Let's quickly revisit that. This looks, yeah, this is kind of what I expected. Like forward was meant to be in the negative z-axis. But we still need to flip that y-axis as well. No, but now A shouldn't, A definitely I want to be negative. Those are the correct magnitudes. Yeah. What is this called? Rotate. Well, we're lucky because we're not actually referring to it. Yeah, okay, so they still go the wrong way. They go the right way. So I think that means that we didn't need to flip this. Good. That is seeming correct now. Let's quickly amend that commit and pretend I didn't ever do that. Okay, right. So we have camera position. I need to bring in the camera angles here. I should factor out camera into a separate class or something. That might be a good idea. A separate class? What am I talking about? Separate module. So once we've got some angles, we can change our forward vector. That's weird. I'm not sure why that's messing up. The forward vector is the rotation of this forward vector by nope, I want the linear library. We need to rotate this, which I think we can do in the quaternion module. Rotate applies a rotation to a vector. So, what is our orientation? I'm guaranteed to get this the wrong way around, so let's see what happens. So, so axis angle. Our axis that we're going to rotate around first is the positive y-axis by x, and then I think you can just multiply these? And then it's going to be around the positive x-axis. So rotating around the y-axis gives us the ability to look left and right, and rotating around the x-axis gives us the ability to like roll our heads up and down. So I've called, yeah, like x here means like x degrees of rotation around the y-axis. If we combine those two together, we get a single quaternion, which represents the orientation that we're looking in. I can translate our forward vector by that, and I can translate our up vector by that as well. I've got quaternions. Yeah, quaternion is imported. Nothing should change so far. I just want to confirm that. Yep, good. So let's just update our model to just rotate us every frame. So we'll step. Do it slowly. Should just slowly spin us around on the spot. Oh, I just realised that camera position also needs to know about this orientation. Okay, I don't know if that's necessarily the correct direction. Not sure what I expect positive rotation to mean. I guess I expect positive to mean looking to the right. Well, that field of view is trippy. We should probably bring that back down to about 90 degrees or something. But that does seem to work. What about pitch? Why is that one way quicker? Or did I put 0.01 on the other one? And then I guess just to give everybody on the stream some serious motion sickness, let's just spin around really weirdly. So there's also some clamping that we're going to have to do here. Pretty. Yeah, that's moving too quickly for me to have any intuition as to whether or not that's correct. So we're looking in that direction, I suppose, so into the top left corner. No, I still can't figure that out. Let's get mouse movement in there and see what happens there. So rotate. So that's keyboard event action. No, it's nothing to do with that. Actually, I will bring that back in. I think it's a mouse motion event. So we want to look at the relative motion. Oh, it's probably, yeah, this is probably quite easy actually. So, quake-3, model, action, no impulse, but the rotate is simply, so this is the amount of pixels that we've moved. So 1 pixel really shouldn't be much of a rotation. So let's maybe divide that by 100. And we need to turn that integer into a double. And I don't know why my syntax highlighting is so messed up. Oh, this is really weird. It's like it's not at all what it should be, because they are only because the left and the right are broken. But oh, and everything's just inverted. Ah, super weird. We've got inverted mouse look on, and nobody plays with inverted mouse controls. That's just wrong. I might allow people to play with inverted joystick controls, but inverted mouse look is just weird. Cool. So I can't. I've lost myself. Oh, so well, there's something we should be doing first, which is locking the mouse in place. Which I think is in the input module. So yeah, we can set mouse location mode to be relative, which basically hides the mouse pointer. Might not be able to quit, but this is what you want to do if you're making an FPS game. Basically, like we don't want absolute mouse motion, and we don't want the mouse to just like hit the edge of the screen and stop moving. So let's change our context when we set up our screen and everything. Once we create the window, we will just set mouse location mode. I thought we added state variables for all this stuff. Evidently not. Set mouse location mode to relative location. So yeah, when relative mouse mode is enabled, the cursor is hidden and mouse position will not change. However, you will be delivered relative mouse position change events. Precisely what we want. Might need to import that. No, it's happy. Cool. So it returns the location mode that it's now in, and in theory it might have failed. So that I didn't want to move that. Right. So with everything correctly set up, what happens? Wow, it's taking a long time to link. Okay, so if I move the mouse to the right, I go left. If I move the mouse to the left, I go right. If I move it up, okay, so now it's inverted. I think what happened before was I spanned the mouse so quickly, I basically ended up turning my head like 180 degrees, which then means that all my axes are flipped upside down, which is just super weird. So I think it was right how it was. The problem is we're not clamping those angles. do I want to write something like... I'm not sure what you mean. Do you mean like, do I want to build like a general game engine? Why is this still inverted? Yeah, if you mean do I want to write a general game engine, like the kind of id Tech engines, not really sure, to be honest. The goal is really to build a Quake-3 thing first. And if we get our API right, we should kind of end up with an engine for free. How actually reusable that engine is something different. But I'm not sure. Like, the goal is really to learn Vulkan and to then implement Quake-3 on that. So I don't understand. Okay, so up and down is correct, but now left and right is wrong. So let's times that. How do I want to do this? Yeah, okay, we can lift multiplication pointwise over that, and I want to negate that and keep that the same. Sweet! We got mouse look. So yeah, so something that's weird now is the direction you move is completely independent of the way that you're facing. So that's kind of weird. But also to be expected. So right now I'm apparently walking backwards and walking forwards. The reason that that's happening is pretty understandable. Our camera position is simply the impulse getting added on. Whereas it should be the impulse rotated by our orientation. So let's take out this render stuff. Yeah, I'm going to copy this in for now, but maybe we can factor this out. So how does this want to work? I guess we want to apply... We probably want to rotate the camera first and then travel in the newly rotated direction. I always find this question interesting. You've basically got two events happening, but the order that you apply them matters. They don't commute. Like if we rotate the camera and then walk along the impulse, that's very different from walking along the impulse and then rotating. And I don't really know what the user's intention would be, but humans are pretty good at figuring things out and building good mental models quickly, so I'll just let them adapt. And I'm going to go with the assumption that it's the direction you were facing at the point of update, not the new direction that you would be facing. So this is you should just need to multiply the movement vector by the matrix orientation. Yep, you're exactly correct. So, but I think the one thing that we're recomputing this orientation quaternion, we're calculating it in two places now, which is obviously a bit redundant. I think we can probably just store the quaternion and keep bumping the quaternion directly here. Need to confirm that. So X, Y. Oh, I don't know if linear exports that. Okay, moment of truth. That looks right to me. So yeah, I mean, like you can see the judderiness here is actually because this is essentially as if somebody was just really fast, like repeatedly pressing the button. So we can smooth that out. I think I'm going to leave the stream there though. This is a good place to stop. We've got a really basic first-person camera implemented. In terms of smoothing that out, we probably need to be writing a proper game loop with a physics time step. So right now, all of this movement is completely based on the frame rate that it's running at. Instead, we should be measuring the time between frames and scaling things accordingly with like a delta time. There's a good blog post on that called Fix Your Time Step, and we'll probably be implementing some of the ideas from that blog post. Yeah, I think this is good progress today. This is now looking less like a Vulkan demo and actually starting to form into something. So I got that code committed and pushed up. We'll probably do next stream, I guess, maybe on Tuesday now. I'm going to be busy all day tomorrow and Monday, so yeah. So as always, I'll be tweeting when I go live on my Twitter account, which is just at acid2. You can also follow me on Twitch, obviously, and get the go live notifications on there. But yeah, cheers for joining me, everyone. Hopefully catch you on the next stream.